Hello dear students. Today again I welcome you all for the course of refrigeration and air conditioning, and today we will discuss another problem of cooling load estimation of your unit number 6, which is also of a different type and a bit important also. So let's begin. The following data refers to the office air conditioning plant having the maximum capacity of 25 occupants. Okay. The outdoor design conditions 34 degrees Celsius DBT and 28 WBT. Inside design conditions are 24 degrees Celsius DBT and 50% RH. Okay, the outdoor and indoor conditions are given in terms of temperature and relative humidity. The solar heat gain is 9120 watt. The sensible heat gain per occupant is 90 watt. Latent heat gain per occupant is 105 watt, and lightning load is 2300 watt, whereas the sensible heat load from other sources are 11630 watt. And infiltration load, the amount of air which is infiltrating in the room, that is 14 meter cube per minute. Okay, earlier whatever the problems we have solved, everywhere directly the values were given for room sensible heat and the room latent heat. Okay, the total heat loads or total heat components which are responsible for sensible heat gain, the components which are responsible for latent heat gain, they were merged together and total heat were given. Okay, the room sensible heat and the room latent heat. But in this problem, this is what the change has been given. The change we can observe here, that total or room sensible heat is not given. Its components are mentioned, that the solar heat which will be responsible for adding up some sensible heat, that is 9120. Okay, whatever the occupants are present, they are releasing some kind of a heat, they are dissipating some heat which is responsible for sensible heat as well as for latent heat. So that is 90 watt, 105 watt. Whatever the lighting arrangement is there inside the room, that going to dissipate 23 watt. And some other sources, some you may have some different appliances in the room, different processes are taking place in the room, you may have partition wall, so everything is there which is going to contribute the sensible heat load as 11630 watt. And another thing which we have seen in the last problem, that is about the infiltration. Okay, the amount of air that leaks into the room, that is 14 meter cube per minute. Now this air which is infiltrating, this is also going to contribute some sort of sensible heat and the latent heat, so that also we need to calculate. Okay, so instead of having direct values of room sensible heat and the room latent heat, in this problem its components are mentioned. We'll have to add them together and we'll have to get the values of RSH and RLH. Assuming 40% of fresh air and 60% of recirculated air passing through the evaporator coil, now it is a cooling coil. Okay, and bypass factor is 0.15. Now this line is important. Assuming 40% of fresh air, okay, and 60% of recirculated air are passing through the evaporator coil or cooling coil, it means the fresh air which you are taking from the atmosphere at 34 dBT and 28 WBT, this air is going to mix up with the recirculated air which is coming from the room. They are mixed together and then they are entering to your cooling coil. So if you can analyze the arrangement of this particular air conditioning plant, you can assume that, or you can conclude that initially there is a fresh air, then there would be a mixing chamber, and after that you will have the cooling coil, and then there would be the room. And whatever the cooling coil you are having, its bypass factor is given as 0.15. And two things you will have to calculate. One is the dew point temperature of the cooling coil, that is ADP temperature, and second one is the capacity of your plant, that is a refrigeration load on the cooling coil. Okay, so let us sort out the given data. Outside air condition, that is 34 degrees Celsius DBT and 28 degrees Celsius WBT. Design indoor condition, okay, the temperature and humidity inside the room, conditioned room, is 24 degrees Celsius DBT and 50% relative humidity. And 40% of fresh air and 60% of recirculated air, they mix together, going to the cooling coil and supplied to the room. Now the different heat sources I have not included here because we will have to use them in the calculation. So let us draw this flow diagram or the schematic arrangement of this particular air conditioning plant. Let me say this is your conditioned space or conditioned room, that is your office, having the indoor conditions 24 dBT and 50% RH. Fresh air which is coming from outside, atmospheric air, 34 degrees Celsius dBT and 28 degrees Celsius WBT. Okay, so 60% is recirculated air which is coming from 2. We have denoted the conditioned space as 2 and we have denoted the fresh outside air as 0.1. Okay, so they will come together, 40% of fresh air, 60% of recirculated air. They are mixing together and after that they are entering to your evaporator coil or cooling coil. So before cooling coil there has to be a mixing chamber. This 40 and 60, this proportion, they will mix together. This total air now you are sending to this cooling coil, evaporator coil, where its air conditioning would be exactly taking place, and then it would be supplying to that particular space or that particular office. Accordingly, I can denote the points 3 and 4 before and after cooling coil. Now, in every problem, first task is to find it out the room sensible heat factor. Okay, RSHF, which we used to represent it on the psychrometric chart. Okay, now in this problem also we will first calculate RSHF, and in order to calculate RSHF we must know room sensible heat load or room sensible heat gain and room latent heat gain. Okay, and earlier problem whatever we have solved, everywhere the directly values were given. RSH was 50 kilowatt, RLH was 15-20 kilowatt. You were adding them and getting the total heat, and by using the formula you used to calculate the RSHF. But in this problem the components are given, the different components of sensible heat load, different components for latent heat load. You will have to pick the correct one, keep it in the formula, and you'll have to find it out RSH and RLH. When we had the theory part of this particular unit, we have covered this much of the components of sensible heat or sensible heat gain, and these were for the latent heat gain. Okay, so inside the room the sensible heat gains are like solar heat gain. Okay, जो solar radiation से heat आ रहा है. Okay, फिर infiltration, infiltrate air जो आ रही है, जो आपकी cracks, door openings, कुछ passages उसमें से जो आ रही है cracks में से, micro cracks, वो एयर जो आ रही है वो भी कुछ हीट कैरी करेंगी. दैट इज ऑल्सो गोइंग टू रिस्पॉन्सिबल फॉर सेंसिबल हीट. Then whatever the occupants are present, as in this problem it is mentioned that the air conditioning is designed for the office where the sitting capacity is 25 occupants. तो वो 25 occupants भी कुछ ना कुछ एक हीट रिलीज कर रहे हैं, डिसिपेट कर रहे हैं, तो उससे भी कुछ ना कुछ एक चेंज आपको मिलेगा टेम्परेचर में. देयर इज एन अरेंजमेंट ऑफ लाइटिंग इन दैट पर्टिकुलर ऑफिस. ओके, so this is also contributing some sensible heat. Okay, and there may be some different other sources. You may have different equipments in that particular room, that particular office, so that is also responsible for giving the sensible heat. So when you will add them together, okay, that would be called as a sensible heat, room sensible heat. And similarly, the two components what we have covered for latent heat, that is latent heat gain from occupants and latent heat load or latent heat gain due to infiltration. So जो दो एयर बाहर से आ रही है, ओके, वो क्या करेगी, उसमें की कुछ हीट आपकी रिस्पॉन्सिबल रहेंगी रूम का एयर का टेम्परेचर बढ़ाने में, और कुछ एयर रिस्पॉन्सिबल रहेंगी आपके रूम का मॉइस्चर कंटेंट डिस्टर्ब करने में. ओके, ह्यूमिडिटी वुड बी चेंज, सो दैट इज ड्यू टू इनफिल्ट्रेशन से. ओके, सो यू विल हैव टू ऐड देम टुगेदर. अब ये सारी चीज़ें प्रीवियस प्रॉब्लम्स में डायरेक्टली गिवन थी कि RSH इतना वैट है, RLH इतना watt है, value substitute करो and get the RSHF. But here you will have to take all the values into the consideration. Now in given data we had these things. Okay, solar heat gain था 9120 watt. We will keep it as it is. अब solar heat gain or sensible heat gain, that should be sensible heat gain from all occupant, that should not be solar, that should be sensible heat gain from all occupant. तो एक occupant से निकल रहा है 90 watt. So such 25 occupancy is there in the room, so 25 multiplied by 90, that is 2250 watt. This is sensible heat gain from occupant. Then sensible heat gain from lighting, that is 23 watt, 2300 watt. Sensible heat gain from other sources 11630 watt. And in terms of latent heat, the latent heat gain from all occupants is 25 into 105, 2625 watt. अब ये जो RSH और RLH के टर्म्स में जितने भी पैरामीटर्स थे, everything we got except the sensible heat load due to infiltration and latent heat load और latent heat gain due to infiltration. सारी चीज़ें आपके पास, सिर्फ जो infiltration से एयर आ रही है उसका heat gain आपके पास नहीं है, ना ही sensible ना ही latent. So first thing is to calculate that particular heat gain ड्यू टू इनफिल्ट्रेशन. तो सबसे पहले आपको वो निकालना है, उसी के बाद आप RSH और RLH निकाल पाओगे. सो फॉर दैट वी विल हैव टू locate point number 1 and point number 2 on psychrometric chart as outdoor and the indoor condition. और उसका स्लोप आप रिप्रेजेंट करोगे पॉइंट ए से, जैसा आपने प्रीवियस प्रॉब्लम में किया था. 1 पॉइंट लोकेट करो, पॉइंट नंबर 2 लोकेट करो, 1 से नीचे एक वर्टिकल लाएंगी, 2 से एक राइट साइड में हॉरिजेंटल लाइन आएगी, दोनों जहाँ इंटरसेक्ट कर रहे हैं दैट इज़ योर पॉइंट ए. एंड दैट पर्टिकुलर पॉइंट, ओके, फाइंड इट आउट H1, H2, HA एंड VS1. VS1 इसलिए इंपॉर्टेंट है क्योंकि आपको निकालना पड़ेगा उसका मास. ओके, नाउ एज यू गॉट ऑल द एंथैल्पीज, फर्स्ट कैलकुलेट द मास ऑफ एयर इनफिल्ट्रेशन इन द रूम. वॉल्यूम दिया हुआ है दैट इज 14 मीटर क्यूब. ओके, एंड specific volume just now you have calculated, that is 0.9, so the mass is 15.56 kg per minute. Fine. So this is about the mass of air infiltrated in the room. Now by using this mass and enthalpy differences we will calculate the sensible heat and latent heat gain due to infiltration. In last problem also we did that. ये दो फॉर्मूले हैं, एक सेंसिबल हीट गेन के लिए और दूसरा लैटेंट हीट गेन के लिए. m1 इंटू HA माइनस H2 एंड m1 इंटू H1 माइनस HA. ओके, सेंसिबल हीट मतलब जहाँ पे सिर्फ टेम्परेचर चेंज होगा, ह्यूमिडिटी विल रिमेन कांस्टेंट. एंड लैटेंट हीट मीन्स द टेम्परेचर विल कांस्टेंट एंड ह्यूमिडिटी विल ऐड और रिमूव. नाउ जस्ट सब्स्टिट्यूट द वैल्यूज and we'll get it in terms of watt, that is 2853 watt, that is sensible heat gain due to infiltration, and 8039 watt latent heat load due to infiltration. Okay, अब एक सिंपल टर्म्स में अगर ये प्रोसेस को समझना है तो आपको साइक्रोमेट्रिक चार्ट पे सबसे पहले पॉइंट नंबर 1 मार्क करना है. ओके, आउटडोर कंडीशन पे. पॉइंट नंबर 2 मार्क करना है इंडोर कंडीशन पे. ज्वाइन देम और फिर उनसे दो लाइंस निकलेगी, एक हॉरिजेंटल एंड एक वर्टिकल, इन ऑर्डर टू गेट द स्लोप लाइक दिस, और वहाँ रिप्रेजेंट करोगे आप पॉइंट ए. नाउ एट दिस पॉइंट यू विल गेट द एंथैल्पीज H1, H2 एंड HA, एंड सिमिलरली एट पॉइंट 1 you should know the value of VS1. Now let us calculate the RSH. अब RSH में इतने टर्म्स हैं, सारी वैल्यूज़ आपके पास है. Substitute the values and get the answer as 28,153 watt. That is RSH. Similarly, find it out RLH. Only two components were there. One is a latent heat gain from occupants and one is a latent heat load due to infiltration. And we got 10664 watt. Now you can easily calculate the RSHF. Substitute the value in this formula which traditionally you are using for calculation of RSHF and get it as 0.725. Now this sensible heat factor RSHF, you can represent it on psychrometric chart. Now on psychrometric chart, at first you will locate sensible heat factor as 0.725 on psychrometric scale. Mark it as point A, and point B you will have to take it as 26 dBT and 50% RH. Okay, and you will have to join them together. And similarly, parallel to that particular line AB, you will have to draw another line through point 2 till it reaches the saturation curve at 5. Okay, so that 2 to 5 line, that will represents the RSHF line, which represents the supply conditions. Okay, and point number 3, now this is also important, as mixing chamber is before the cooling coil. So from point number 1 the fresh air is coming, and from point number 2 the room air is coming, recirculated air is coming, and they're mixing together, and it gives you another quality which can be represented at point number 3. In order to get point number 3, you will have to multiply that length 1 to 2 by 0.4. Okay, 60% is recirculated air and 40% is fresh air. So measure that length 1 to 2 and multiply it by 0.4. You will get 2 to 3, and at point number 3 you will get a temperature 28 degrees Celsius. Okay. Same thing, same processes, same steps what we have covered just now, we will do it on the psychrometric chart. Okay, so this is your psychrometric chart, and left top corner you can see the schematic diagram of your air conditioning plant or airflow diagram. Okay, at first locate point number 1, that is 34 dBT and 28 WBT. Point number 2, that is representing the conditioned space, 24 dBT and 50% RH. Join them and you can represent point number 3 on this. ये 1 से 2 का जो लेंथ है इसको आपको मेजर करना है. ओके, 1 पॉइंट था फ्रेश आउटसाइड एयर का कंडीशन, और पॉइंट नंबर 2 था दैट इज अ कंडीशन स्पेस. मेजर दिस लेंथ 1 to 2 एंड मल्टीप्लाई इट बाय 0.4, एंड आफ्टर मल्टीप्लाइंग जो भी डिस्टेंस आएगा दैट शुड बी योर 2 to 3. Okay, so this 2 to 3 is nothing but length 1 to 2 multiplied by 0.4. Now after representing this point number 1, 2 and 3, locate sensible heat factor on that particular scale as 0.725 with point A. Point A है आपका, and then point number B. Point number B, that is your alignment circle. Alignment circle, always it is 26 degrees Celsius dBT and 50% RH. Join them together, you will get a line AB, and parallel to this line AB you will have to draw one line through point 2. AB line को parallel एक line draw करोगे आप point number 2 से till it reaches the saturation curve, like, और जहाँ पे भी ये saturation curve को intersect करेगा वहाँ पे आपको locate करना है point number 5. Now point number 5 you have represented, that is RSHF line. Now you got point number 3 also. Look at that cooling coil. Cooling coil के जो entry पे mixed air आ रही है उसका लोकेशन आपने रिप्रेजेंट किया है पॉइंट नंबर 3. अब 3 से जो एयर आ रही है वो जा रही है कूलिंग कॉइल में, और जब बाहर निकलेगी देन इट वुड बी एट पॉइंट नंबर 4. एंड यू नो दैट 2 to 5 is supply air line, or you can say that it is a line on which you can represent the supply conditions. Okay, so obviously your point number 4 that would also be lying on that 2 to 5 line. Okay, point number 4 भी आपका 2 से 5 की लाइन पे आएगा, but you don't have the value of 4, you don't have the value of 6 also. कूलिंग कॉइल का भी आपको टेम्परेचर नहीं पता, तो सिंपली आपको यूज़ करना है बाईपास फैक्टर का एक फॉर्मूला, एंड बाय यूजिंग ट्रायल एंड एरर मेथड you will have to get the value of T4 and T6. Okay, जब आप बाईपास फैक्टर यूज़ करोगे, ओके, तो बाईपास फैक्टर में कौन सी 3 चीज़ें आएंगी, 3 टेम्परेचर आएंगे. एक आएगा इनलेट एयर टेम्परेचर दैट इज़ TD3, एक आउटलेट एयर टेम्परेचर दैट इज सप्लाई एयर टेम्परेचर TD4, एक आएगा आपके कूलिंग कॉइल का टेम्परेचर विच वी जनरली यूज टू रिप्रेजेंट इट एज TD6 और बाईपास फैक्टर 3, 4, 6 एंड बाईपास फैक्टर। ये फॉर्मूला आपको यूज़ करना है और ट्रायल एंड एरर मेथड से फाइंड आउट करना है TD4 एंड TD6। तो TD6 अगर आप बाईपास ट्रायल एंड एरर मेथड से फाइंड आउट करोगे यू विल गेट इट अराउंड 7 to 8 के बीच में। Okay, and whatever the value you will get, that I got around 7.4, so that 7.4 I will mark it on this saturation curve as ADP temperature. Okay, और उस पॉइंट से एक लाइन ड्रॉ करूंगा मैं till it reaches the point number 3 like this, and wherever it is intersecting 2 to 5 line, there I will locate point number 4. So this is how you can draw the processes on psychrometric chart. अब यही ट्रायल एंड एरर मेथड वी कैन सॉर्ट इट आउट। बिफोर दैट वी कैन सी दिस प्रोसेसेस अगेन ऑन द लेआउट ऑफ साइक्रोमेट्रिक चार्ट। Okay, 34 dBT, 28 WBT, that is 0.1, 24 degrees Celsius dBT and 50% RH, that is 0.2. Join this, represent point number 3, locate point A and point B, parallel to this line AB, draw one line through point number 2 till it reaches saturation curve, that is 2 to 5, and then you will calculate the TD4 and TD6 temperature by using the formula of bypass factor and trial and error method. तो उससे आपको मिलेगा TD6 और 6 से ज्वाइन करो 3, जहाँ पे इंटरसेक्ट करेगा पॉइंट, जो पॉइंट मिलेगा इंटरसेक्शन का 2 to 5 और 3 to 6 का, वहाँ रहेगा आपका पॉइंट नंबर 4। ओके, TD6 इज नथिंग बट योर ADP। अब जो फॉर्मूला आपने यूज़ किया दैट इज नथिंग बट दिस, bypass factor is equal to TD4 minus TD6 upon TD3 minus TD6। आपको इसमें निकालना है ड्यू पॉइंट टेम्परेचर और ADP टेम्परेचर। ऑल द वैल्यूज आर नोन एक्सेप्ट TD6 एंड TD4। बाईपास फैक्टर भी प्रॉब्लम में गिवन है, सिर्फ दो टेम्परेचर नहीं है आपके पास, एक पॉइंट नंबर 4 और दूसरा पॉइंट नंबर 6। अप्लाई ट्रायल एंड एरर मेथड and get TD4 as 10.4 and TD6 as 7.4. Okay, and last, capacity of the plant or refrigeration load on the cooling coil. सबसे पहले कैलकुलेट करोगे आप मास निकालने के लिए पहले आपको एंथैल्पी पता होना चाहिए हर एक पॉइंट का। मास आई विल यूज द सेम फार्मूला विच वी हैव यूज इन द प्रीवियस प्रॉब्लम्स, RSH प्लस RLH अपॉन H2 माइनस H4। ओके, ये टोटल उस पर्टिकुलर रूम में जो एयर आ रही है उसका मास है। तो रूम के पहले सप्लाई एयर थी, रूम के बाहर रिसर्कुलेटेड है। सप्लाई एयर पॉइंट नंबर 2, सप्लाई एयर पॉइंट नंबर 4 एंड रिसर्कुलेटेड एयर पॉइंट नंबर 2। ओके, सो दैट्स व्हाई आई टेक H2 माइनस H4। इस पे से आपको मिलेगा मास। आई गॉट इट 2.15 kg पर सेकेंड। अब कॉइल में जो एयर आ रही है वो आ रही है पॉइंट नंबर 3 पे, और कॉइल से जब बाहर निकल रही है तो वो निकल रही है पॉइंट नंबर 4 पे। सो दिस पर्टिकुलर 2.15 मल्टीप्लाइड बाय H3 माइनस H4 वी विल गेट एज 4515 kg पर मिनट। सेकेंड से मिनट में कन्वर्ट करना, दैट्स वाई वी हैव यूज मल्टीप्लिकेशन विद 60 एंड डिवाइड दैट टोटल टर्म बाय 210, वी विल गेट 21.5 TR. So this is how we have calculated the refrigeration load or the cooling capacity of the plant. Thank you.